We discuss several anomalies in LP model. The first one we call alternated optimal solutions. The second one is redundant constraints. The third one is unbounded solutions. The fourth one is infeasibility. As we can see in this graph, the level line of the objective function will touch the entire area of the feasible solution. So in this case, the point from the first extreme point to the second one, the entire line will be the optimal solution for this linear programming model. So all these optimal solutions, they are going to give you the same objective function values. We call them alternated optimal solution. Sometimes we also call multiple optimal solutions. The second case is the redundant constraints. In this case, as we can see, the pump constraints, as we single out over here, will not touch any of the feasible area. So the pump constraint actually does not define our feasible area and become redundant for the entire problem. So once we solve for the optimal solution, we do not need to consider the pump constraint. The third anomaly is the unbounded solution. In this graph, we have a feasible area going infinitely to the right-hand side. And we have one objective function is try to maximize the value. So if we move the objective function line x1 plus x2 outward to touch the last point of the feasible area, we find that actually we will never find the point because the entire area is infinite. So this problem becomes unbounded for us. It means we cannot find the optimal solution point. Mathematically, it's fine to have unbounded solution, but in practice, if you have a problem could not give you a limited solution, instead you have unbounded solution, it might tell you that your model actually is wrong. Because you are not going to go back to tell your manager that you have unlimited profit for your company. The fourth anomaly is the infeasibility. In this graph, we can see that we have two constraints. The first one is x1 plus x2 equal to 200. And the second one is x1 plus x3 equal to 150. And we know that it's impossible for us to find any area satisfying both constraints at the same time. So we call this problem infeasible because we could not find the feasible area. In this case, you should tell yourself, actually your model could be wrong because you cannot find any feasible area. And you are not going to go back to tell your boss that you could not find any feasible solution because likely your boss will ask you to go back to redefine the model. Thank you.